Hello guys, let's quickly talk about integral of root tanx dx. In the next video, we may treat cube roots till in the next one we continue till we get to probably fifth roots. But let's start with the basic. We are laying a foundation that will help you in the advanced aspect. So integral of root tan x dx. Now we bring in variable u. Let u be what? Root of what? Tan x. We say let u be root of tan x. If you square both sides, that means your u square equals to what? Tan x. Because if you square this, the root will remove. If you square this, so differentiate u square, you have what? 2u du. If you differentiate tan x, you have what? Sec square x dx. Make the the set of the formula. Divide both sides by sec square x. Divide both sides by what? Sec square x. Sec square x cancel sec square x. That means dx equals to what? 2u du over what? Sec square x. So ds is what? 2u du over what? Sec square x. Now what's the next thing now? Now, if don't forget there is a trig identity that say sec square x equals to 1 plus what? Tan square x. Do we remember? And if tan x is u square, what will be tan square x? If tan x is u square, if you square tan x to give tan square x, that means this will be u raised power 4. So that means sec square x equals to 1 plus. If tan x is u square, tan square x will be what? U square square, which is u raised power 4. Do we get? So now let's rewrite the question. Now the question now becomes integral of root tan x. What's our root tan x? We say let it be u dot dx. What's our dx? No, root tan x dx. And we say let it be root tan x u dot. What's our dx? 2u du. Our dx is 2u du over what? Sec square x. What's our sec square x? 1 plus u raised power 4. Do we get? So that's, yeah, I'm coming. Yeah, 1 plus u raised power 4. I hope you can see that. So let me write it at the top so that sorry for the little space. So now we've obtained integral of what? U times 2u. So here give us 2u square over 1 plus u raised power 4 du. Don't forget where we are coming from. Initially you say u equals to root of what? Tan x. Let's keep that. Let's keep this. This is the initial condition, initial substitution that we did. So because we need it at the end of the day. Now 2u square is same thing as, I can change this question to integral of u square plus 1 plus u square minus 1 over 1 plus u raised power 4 du. U square plus u square, 2u square. 1 minus 1 is 0. So 2u square is same thing as everything here. So the question can change to integral of what? U square plus 1 over 1 plus u4. I would prefer to write u4 first. u4 plus 1. 1 plus u4 is still u4 plus 1. Plus what? U square minus 1 over what? U4 plus 1. Close bracket. Du. Do we get that? So now I want to split the integral. I want to split the integral now. So here I will now have integral of, now the first part is u square plus 1 over u4 plus 1 du plus integral of u square minus 1 over u4 plus 1 du. U square minus 1 over what? U4 plus 1 du. Do we get that? So I've splitted this. This carries the du. This also carries. So I've splitted it. Now the next thing, now divide everything in the question by u square. Yeah, divide everything in the question by u square. It's because of a standard integral. We want to bring that standard integral. That's why at times if you have not seen a question before or solve it, you may not know what to do. But if you've seen it, not just seen it, if you learn it and you understand it, then some other question will be very familiar with you. Now I want to divide everything by u square. If I do that, I will have u square over u square. This will give me 1. 1 divided by u square. Here we have 1 over u square. U4 over u square, we have u square. 1 over u square, we have 1 over what? U square. Du plus integral of u square over u square 1 minus 1 over u square, 1 over u square over u4 over u square, we have u square plus 1 over what? U square du. Actually, I've not changed anything. It's just like I divide the whole numerator by du. I divide the whole denominator by du. If I cross multiply by u square rather, if I cross multiply all the u square will cancel back, I will have this original back. This what I wrote here is just like saying, no, this u square plus 1, just like saying u square plus 1 over u square. No, you can write it as u square over u square plus 1 over u square, and this one will turns to 1, this one turns to this. So if I divide the numerator by u square and the denominator by also u square, if I cross multiply, u square will cancel u square, it will give me this question back. So there is no problem. Since I can split it that way to just turn this to 1 and this, then I can just divide each term by u square, just like. So there is no problem. So this is what we obtain now. Now what's the next thing to do here from here? The next thing is that now we are going to use completing the square method. Now what is the completing the square method? Now note that u square plus 1 over u square can be written as u plus 1 over u all square minus 2, using completing the square method. Yeah, if you use completing the square method, you can confirm that u times u square, u times 1 over u 1, 1 over u times u 1, 1 plus 1 2, 2 minus 2 0. This, see, expand this, you are going to get this. That's just it. Expand this, you are going to get this. Write it in your note and expand this, you are going to get this. Now this one too. Now for this one here, for this other one, though they are the same but I will not use this for this one, because of I want to cancel this. So I can also write this in another form by saying u square plus 1 over u square equals to u minus 1 over u all into square plus 2. Yeah, both this, this is plus and minus, this minus and plus, both are equal. Expand it, you see that they are actually equal. For real, they are equal. So it's because of the numerator that I changed those ideas. Please take note of that, don't be confused. So now what we are now going to do is that, let me clean this part. Sorry for the space, I'll try and get a bigger board. So yeah, I'm having integral of 1 plus 1 over u square divided by, instead of this now I will write this, divided by u plus 1 over u all into square minus 2, but I will write minus 2 as minus root 2 square. Do we get? Du plus integral of, look at this identity, take note of it. That's what I want to write next. I want to write it next, but I'm cleaning it because of space. Plus what? Integral of 1 minus 1 over u square du divided by, now the identity for this can be written as what? U minus 1 over u all into square plus what? Plus 2, which is root 2 square. Just follow what I've been doing, there's no problem. So this is what the question has turned to. Do we get that now? Now what you are now going to do now, do you know what you are going to do? Now saying let v, you bring in another identity, let v equals what? 1 plus what? 1 over u square. And you can say let w be equals what? 1 minus what? 1 over what? U square. Now if you say let v be this, let v be this numerator, let w be this one. Now if we differentiate this guy, what are we going to get? Oh, sorry, we are using the inside, not the outside. Let u be the denominator, let me bring in another, let me say let a be what? U plus 1 over u, and let b be equals to what? U minus 1 over what? U. Let a be this, let b be this. So if you differentiate a, dA over du, if you differentiate this here, we have 1. If you differentiate 1 over u, you have minus 1 over u square. So if I differentiate 1 over u, yeah, I will have minus 1 over u square, minus 1 over u square. So in this course, I will love to change this guy to this, like to, the denominator are actually equal in the first place. So I would love to change this one to this one. I will love that. So let me put this one. They're actually the same thing, so I would love to change this to this. Do we get? So db over du, this one will give me 1. If I differentiate 1 over u, I will get minus 1 over u square times minus plus 1 over what? U square. Do we get? Now let's make du the subject of the formula. If you make du the subject of the formula, that means du equals to dA over 1 minus 1 over u square. 1 minus 1 over u square. Here, make the du the subject. Here, du will give you what? dB over what? 1 plus 1 over what? U square. Do we get? Now, what are we going to do next? What we are going to do next is, please write this, keep it, keep this in your notes, keep this in your notes. Okay, let me just be cleaning it one by one. Now, the thing now is that if this is du, now if we put, no, we already said let A be this listing. We already said let A listing because I don't want to clean it. We already said let A be where is it self? I'm coming on. Oh, please listen. You know, I changed the sign here earlier. I changed the sign here earlier. So this I changed this earlier. So sorry. So this is minus. No, this is the one we are using now. So if you differentiate now, this will be plus. So since I changed this earlier, so this one will be the plus. Then since we differentiate, this will be minus minus. Do we get? No, I changed it earlier. Like I prefer to use this one for this for this. So this is our A is this inside, which is this. If you differentiate, write this in your note and differentiate, you will get this. Our B is this inside, which is this. If you differentiate, you get this. Now listen now. Now here is the main issue. No, we said let A be this, right? So I want to clean this and put what? And put A. So here we have A square plus root 2 square. Do we get? Now du, what's my du? No, du is here. What's my du? My du is dA over this. My du is dA. Now, no, you get this. You know, this is, we have square of this here before. Since we say let's A be this, here I have A square plus this. Now, du now, since I've changed this to A, this must also be in form of dA. Now, du is dA over this now. If I put dA over this here, this guy, we cancel this guy. So here we will have dA alone. This we cancel. Do you know how we cancel? It's because of space I'm doing this, but I hope it's clear. Now we said let B be this, so that means whatever we have here will be B square, right? B square minus root 2 square. Now du, what's our du? dB over this. Now if I put dB over this here, this we cancel this, so here will now remain dB alone. I hope that's clear. Just it's very easy to grab that way. So now let me now rewrite the integral. The integral can now be write as integral of what? dA over what? A square plus root 2 square plus what? Integral of what? dB over what? B square minus what? Root 2 square. Do we understand? So don't forget where we are coming from. If we've already gotten the answer now, don't forget the beginning. We say let u be what? Root tan x. Don't forget. And we also say let a be what? What do we call a the other time? You say let a be um ah is it u minus 1 over u, and let b be what? U plus 1 over u. Is that what we call it earlier? Yeah, I think that it should be. So don't forget all these things that we say let. This is from the beginning. This is the earlier one that we substitute. Now we know the standard integral for this guy. The standard integral for this guy, let me write it at the top so that I can have space. This integral of what? dA over what? A square plus root 2 square plus integral of what? dB over what? B square minus root 2 square. So let me clean this. Now we know the standard integral for this is what? 1 over, there's this standard integral that say integral of dx over s square plus a square equals to what? 1 over a tan inverse of what? X over a. Yeah. So we want to apply it here now. Our a is like root 2, this like our x. So yeah, this guy will give us 1 over root 2. No, so yeah, 1 over root 2 tan inverse of what? A over what? Root 2 plus there is this one too that says integral of dx over s square minus a square equals to 1 over 2a ln 1 over 2a. We can prove it, but this standard integral, you need to know ln open bracket um x minus a over a plus x, if I'm not mistaken. I'm coming here, let me confirm that. Yeah, I think it's um a minus x over a plus x ln a minus x over a plus x standard integral. Maybe I'll send a picture of the standard integral. Maybe this is a minus s or x minus a. I'm sorry about that, but we send it. Just understand what you are. This is standard integral. If you have it minus this, it. If you have it plus this, the standard integral. So even though we can also have this in form of this standard, this will be plus first, then minus. If it is this having identity of the, it can also have identity of the, but this will be plus. But for this minor, it doesn't have something like this, only have something like this. So how can we transform this to this? So here now we can say plus our 1 over 2a, our a is like root 2. So here we have 1 over 2 root 2 ln a, that's root 2 minus b over root 2 plus b. Do we get? Should it be root 2 minus b or b minus root 2? Whether b minus root 2, just pardon me if that's not root 2 minus b or b minus root 2, either of the two. This one, whether this plus this or this plus this, is there's no problem. So please, those standard integral, I think what we solve now is well understood, but those standard integral is what we should know. Standard integral for this is this. Without, you don't need to prove it, except if this is the original question, you cannot prove. But since this is where you get to when you are solving a particular question, you can just put the standard integral direct. So this is the final answer, but we need to substitute back. We need to put a. What's our a? This. So this one becomes 1 over root 2 tan inverse of what? What's our a? U minus 1 over u divided by root 2 plus 1 over 2 root 2 ln root 2 minus, what's our b? Our b is u plus 1 over u divided by root 2 plus what? U plus what? 1 over what? 1 over u. Do we get that? But we are not yet done as well. We are not yet done. Now the last aspect, don't forget that our u is what? Tan x from the beginning. From the beginning. So here we have the final answer now becomes 1 over root 2 tan inverse of what? Tan x minus 1 over tan x divided by what? Root 2 u minus 1 over u tan x. You can be finding the LCM. Tan x minus 1 over tan x. You can find the LCM there. There's no problem. Tan inverse of this. Do we get? Plus 1 over 2 root 2 ln root 2 minus u, what's our u? Tan x plus 1 over tan x divided by root 2 plus u. Sorry, our u is root tan x, not tan x. Sorry, our u is root tan x, root root u root tan x plus 1 over u, 1 over root tan x. That's the final answer. See, what I just did is not even to give you final answer, is the understanding. No, this thing is kind of rough. There's no space. I will try and do the video again. I'm sorry, to find a bigger space. But I hope you understand all the rest. Our final answer, our major answer is the first one we get before we substitute this and this. The substitution is not easy because you know the value of u and value of a and b before. But that place we arrive at in that thought to the last answer is that's where it is most important. Please take note of that. Thanks for watching. See you in the next. I might do this one again or move to tanx next. Please drop comments. Let me know your view on this particular video. Let me know your view.